Moving to section 11.6, what we're looking at here is an idea called a complement, where we're not talking about something that is nice to something else. We're talking about something that's actually a thing we've seen before a couple times, where in chapter 2 we used the same name but a slightly different notation, and in chapter 3 we used a different name and a different notation for more or less the same thing, as we're seeing 3 different sets of language for Boolean logic, Boolean algebra, and it's what we got in this class. Anyway, here the idea of a complement is the same as when we're looking at complements of sets, as well as the same as when we're looking at negations with statements. That is, we're looking for the probability of something not happening. We're looking for the opposite in terms of probabilities, where we denote this E prime in this class. In other classes you might see E bar as well, and, or for that matter, even E with a C as a superscript. But point is, we have that where the probability of the event happening or the probability of it not happening, that is PE plus PE prime, is equal to 1, which should make sense because 1 is for a guaranteed thing, and whatever we're looking at here, either the thing we want to happen does happen, or it doesn't. Those qualify, those quantify, those describe all possibilities, so the probability of getting either of them, which is a language we'll talk about a bit later, should cover all possibilities, that is, has probability 1. Where more usefully, more meaningfully, if we want to get the probability of some event that might be a little bit complicated, we can use the opposite event, which might be simpler, and say that the probability of E is also equal to 1 minus the probability of its complement. So one thing we could think about here in terms of our last set of examples from the last section would be something like that survey, where if we want to find the probability of someone being older than 35, P of, let's see, how would I do that there? I think it's this way, 35, which means I might have gotten a notation backwards earlier, but hopefully I didn't. We could look at this, thinking back to our numbers, in terms of each of the parts, 254, 195, and 58. Again, this is sort of notation we'll talk about more later, all over 975, which would, getting us a more approximate, decimal value of 0.52, is, up to rounding, the same as 1 minus the probability of, at most, 35, which is what we had last time. The probability of 18 to 22 or 23 to 35 because they weren't surveying Myers. So, we have that same value gotten in the opposite direction, as it were, where this isn't the most instructive sort of example we can have for complements. Another thing you could think about here might be something where if you want to find the probability of getting a 3 on a fair die, remember that there's only one 3 on a die with 6 sides. Well, assuming it's a standard one, you could make all of the sides 3, but that wouldn't be very interesting unless you're trying to cheat for some reason. And then instead talk about the other 5 options. So if you want to get a 3, that would be the total probability 1 minus the probability 5 out of 6 for everything else, 1 out of 6 for the same reason. Where, yeah, again, not super useful just yet, but the best thing we have there is when we're trying to find, say, at least 1, because the opposite of at least 1 is 0, but that, again, hints towards things we'll see later when we start talking about addition and what it means to say either or in terms of probability. So before we get to that, let's do one more example here in terms of the things we saw earlier. From our example on fatal police shootings, what we want to find here is the probability that the person shot is not white using a complement. Where for this, what we want to do there can be done in terms of all of the options that are not white, which is, again, really weird sort of phrasing to think about here. And you can get that in terms of each of the 3 components in those groups in the survey there, or you can remember that what we had for the probability of one of them being white was that value of approximately 0.507, which should have been a little bit wigglier there to get the probability of anything else being 0.493, which is to say there's about a 49% chance that given any randomly selected fatal police shooting, the person involved was any race other than white, where again, we mentioned earlier the idea of looking at this demographically, understanding the context here, that if you check the numbers specifically from the census, you would see here that the percentage of people who identified as white and not Latino was about 60%, which means that in this data, as we said, the white people were a bit underrepresented and everyone else is a bit, well, overrepresented. But again, it's a complex situation where you really should have a whole bunch of other classes looking at this stuff in greater detail. So let's keep talking about some probabilities instead, where we're going to develop those ideas of either or along with something called mutual exclusivity to better handle our cases.